Firstly, we'll talk about what the end goal of automation is, and then to kind of quote Rob Sonny this morning, asking why we aren't there yet. Then I'll talk a little bit about some pragmatic steps of how we can deliver the autonomous RAN before jumping into some conclusions. Okay, so firstly, why is Amdocs here? Why is Amdocs a silver sponsor of this event? Amdocs is a very large organization spanning software from the BSS to the OSS and to the systems integration world. But we have a very significant footprint in the mobile space, both in terms of services and software. So what you can see on this slide is you can see some of our kind of key customers spread geographically around the world, and our offerings that span software automation to services to do the engineering itself, and also spinning into the kind of fiber space too. So we think we bring in a really independent view of what's going on in the RAN automation space, and our insights that cut across multiple customers and multiple vendors are something we think will be very valuable for people to understand. Okay. So I think, listening into the sessions today, I think it's very clear that everyone knows where they want to be. I'm going to have to. So everyone's trying to move from kind of a very manual set of network operations through to the level 1, level 2, and onwards to level 4, which is kind of a highly autonomous network itself. And I think as the person from Axiata said, we're in quite a unique position at the moment in the sense that a lot of mobile operators have underinvested in automation, and so there's an opportunity to jump straight from level 1.5 to level 4. And what we're seeing is a lot of operators making announcements, the Telefonicas, the Oranges, and others of this world, of their intentions to move to a level 4 kind of level of autonomy within the next 3 to 4 years. And they expect to see 30 to 50% improvements in the efficiency as a result of that journey itself. So the first question is, how are you going to get there? Well, luckily, there's a bunch of breakthrough technologies that are emerging in the market space that are making this happen. So, we've seen a lot of talk about observability and telemetry, and that type of vocabulary is now entering the telecoms space. And so what we're seeing is this groundswell of data coming into the networks itself. There's also innovations around open automation. So you heard a little bit this morning about the service management and orchestration and the RIC, bringing these new open platforms where you can build apps that cover the span of the full radio access network lifecycle. As you'll see a little bit later in my presentation, there's also been a lot of innovation around radio digital twins, and Amdocs is pushing this technology very hard, and we've got a customer success story to talk about around that space. And finally, everything's agentic now. It'd be very remiss to have a presentation that doesn't include agents. And obviously, with the vision that people have of plugging everything into these intelligent kind of systems that make decisions without human intervention, the agent technology is getting a significant buzz. And then finally, we've got the kind of grand 6G vision of AI and RAN, AI for RAN, which will further embed automation and intelligence into the network itself. So, problem solved. We've got all the technologies, we just have to deploy them. But this is where it gets interesting, because we've been in this situation before. So this is a Gartner hype cycle, which everyone is familiar with. And this is the Gartner hype cycle from 2015. And so you can pick out individual technologies here, like natural language question and answering, augmented reality, quantum computing. And all of those made similar promises to be able to transform the entire network space. And according to these diagrams, some of these would hit within 5 to 10 years. And I think one of the interesting ones is in 2015, autonomous vehicles were only 5 years away, according to Gartner. So we've never been short of technology. And there's a natural tendency in the industry to pick up on the latest technology and try to solve all of your current operational problems with that capability. And just as a kind of questioning point, with my skilled use of ChatGPT, I created this cartoon image, which is to kind of convey the fact that there's a technology hammer that you you hit everything with to solve all of your current problems. But interestingly, ChatGPT didn't get it right. It created this kind of strange hybrid hammer hitting various things that look like nails, but also includes a severed human head, a dog, and a pizza on a bike. So it's kind of, what I'm trying to say here is that technology's never really been the problem. It's been the application of that technology that's caused the issues. So how do we kind of break this cycle? Well, and before that, we'll talk a little bit about there's still a lot to be automated. So we've got this situation, we've got a lot of great technology, we've got a lot of kind of capabilities to drive automation, but pretty much we're in the same position that we've been for the last decade or so, in the sense, you can go to an operator, look at their automation landscape, and what you see is hundreds of automations spread across many different smaller platforms, each trying to automate one piece of the story. You've got the OSS systems, you've got legacy SON systems in that place, you've got Excel even, and a lot of manual processes. Good for the industry, you're starting to see a lot of people with Python and AI skills coming through, and they're starting to build their own technology stacks to do this level of automation. So what we've seen is this great influx of technology, but this has led to even greater fragmentation in the automation space. And so even though in theory we should have solved all the problems by now, we're, if anything, a little bit further away than we thought. Okay, so this is kind of our vision about how to deliver the autonomous RAN, and we've broken it down into 3 principles. One is that openness remains critical. It's very key to have open systems that allow data integration, that allows systems to talk to each other, and you don't retreat into proprietary silos. The second one, which is something that we're learning with a lot of operators we're working with today, is that it's very important to create feedback loops that kind of drive automation or automated automation. So in a way, you're not pulling automation up, you're getting, automation is being built for you by the people in your organization. And an interesting, more recent one, working with an operator, is that although the focus in this space is around agentic, one of the key things that we should be doing is building capabilities that support human and agents. So operators already have intelligent agent capabilities in their organization that know the domain well, that know the systems that operate the network well, and they are called human beings and engineers. So as we're building out capabilities for these agentic approaches that will come, there's some nice intermediate steps where you can provide human beings themselves with the tools that they need. Okay. Let's start with the first one. So openness remains critical. So these are the presentation slides that were presented last year at FYUZ, talking about why Open RAN and openness doesn't just mean about the network technology itself. And what we spoke about were a number of areas where openness is important. So open integration, the ability for third-party services companies to integrate the network, open interfaces, which are still incredibly important as being defined by 3GPP and the O-RAN Alliance. And then finally, we spoke a lot about open intelligence. And these are these flexible, open automation platforms that let you pull in information from many different sources and to manage multi-vendor environments. So I think the good story is that there's still this desire in the industry to keep network infrastructure and keep these ecosystems as open as possible, despite the kind of the tendency for network equipment providers to kind of retreat into silos. So keeping, openness being critical is something that's a consistent message and operators need to continue to embrace. And this was the open automation side from last year's session, and this kind of pointed out that you've got multi-vendor, multi-technology networks, and what you're really trying to do with automation is to consolidate all your automation on a single platform that works across vendors, that works across technologies. And the only real way you're going to establish this kind of stable base where you can build and automate more is to take a cross-vendor approach. So we presented this last year. So what has Amdocs been doing? So I'm going to present a kind of a mini case study on this. So earlier this year, we released our kind of cognitive RAN automation solution. This is something we've been working on for the last 3 years with various different operators, and this embodies all those principles of openness. It's a service management and orchestration, non-real-time RIC solution that provides a standard open API where you can build automation either from our apps themselves or software agents. So this provides a solid platform for building all your automation, be it from all of these different sources that you're trying to add to the network itself. And I think broadly the industry's accepted this as the approach. No one's really talking about proprietary closed APIs. They're all talking about creating these ecosystems of app providers that work against a standard SDK. I think what the industry is not talking about as much is the fact that the actual platforms themselves need to be open. So this is the O-RAN Alliance defined kind of blueprint for service management orchestration and the RIC. And this already defines a very modular architecture where you've got an automation capability, you've got the ability to bring in digital twins, you've got a flexible AI and ML model framework. And I think for operators going forward, it's very important to establish these open blueprints where maybe Amdocs does have the best RAN automation engine, but maybe your AI and ML models are already pre-built in AWS. So what you want to do is bring in the best of both worlds and plug in to these very pragmatic infrastructure. Because the last thing you want to do with Open RAN or the open network automation is to create new silos that you'll have to worry about in 5 to 10 years time. So this is the journey that Amdocs has been on. We're a legacy SON provider as well, and we've been working with our customers to bring through these new technologies that give them these open platforms for the future. We've got a stand here, so I won't bore you by going through each of these individual apps themselves, but we have a set of apps and app partners that work with us to build out the kind of capabilities that do this automation. And one of the case studies that we've got here is around energy saving. We're working with a number of operators on this capability. And what this does is obviously take insights into the network, telemetry from the network, build pictures of when the network is quiet and when what type of thresholds can be applied, and creates new policies for energy saving that allow energy to be saved on the network, either directly by controlling the network or more typically by optimizing vendor parameters. And so this is just one of the types of apps that can be built on these type of platforms. And I think the interesting thing to point out on this is that you can see that this disaggregation of the platform itself. So you've got kind of separate capabilities and automation layers for defining the policies, for controlling the network, and you've got separate modules within the AI and ML framework that can learn these patterns in the network. So what you don't have is these monolithic proprietary pieces of software. You have a very kind of pragmatic approach where you can take AI and ML models that we've trained or that you've already trained, plug them into this infrastructure and get the results. And this kind of plug and play nature of apps and infrastructure will build you an environment where you can confidently say over the next decade or so, you're keeping pace with technology, you're not committing to one specific stack. Okay. So that's kind of reiterating why openness is important, why not going down proprietary routes is critical. But let's talk about the second part. So you've got these great open platforms. How do you bring this automation in? And how do you create the situation where it's much easier to automate than it is to do something manually or create a new application to do that automation itself? And so really it's about achieving automation at 10 times scale. So if you look at where a lot of operators are today, is that they've got some 3GPP SON apps, either from a legacy SON provider or from their network equipment provider. And they're starting to move towards a more open environment. So they're bringing in these open automation platforms. They're starting to bring in third-party apps. And that's taking the number of automations from 6, 10 to 10 or 20. But then how do you go further? Well, one of the technologies that we're working with an operator on is something called generative automation. So that's how do you simplify the difficulty in building new automation more quickly. So how do you get the domain knowledge from the experts? How do you combine programmers and engineers together to deliver these new automations? And this is where generative automation comes in. And we think that will get you up to 50, 100 plus automations all by itself. But I think the key step next will be self-service automation. So enabling engineers, non-programming experts, to get their domain knowledges into these type of platforms. And I think as soon as you kind of enable engineers to build their own automation where they don't have to go begging to a central organization to get automation done, you'll get these very positive feedback loops where engineers will spot problems and then build the solutions and automate them automatically for you without having to need large programming teams to deliver that. And so this is the approach we're working with a number of operators on, and I think, we're seeing operators roughly around this kind of expanding out on third-party apps, but now thinking, hang on, there's a lot more automation to manage. How do I really consolidate my automation onto the platform itself? And so talking about a case study, so like I said, one of the challenges with automation is uniting that kind of development angle and the engineering angle. And we have something called Son Code Expert, which is focused on generative automation. And what that does is bring together SDK documentation, vendor documentation, vendor parameters, engineering requirements, and allows them to be brought together in an LLM and do a couple of tasks. One of those tasks is spec to code, where you can write software specifications or radio engineering specifications and get that converted into code. The other one, quite interestingly, that's getting a lot of use is code to docs. So there's a lot of code that already exists out there in automation, and what you really want to do is take that existing code and turn it into specifications as a preliminary step to migrating that automation over to these new platforms. And one of the interesting challenges that comes up when you're managing very large code bases is that it's a software development activity. If you've got 150 automations that have been built, you've got to maintain those automations when the vendor's APIs change, when KPIs change. You need to make sure that all of these 150 apps get kind of brought up to the latest kind of versions. And obviously the generative stuff works very well on that, being able to transform existing code into new optimized code for the new types of inputs. So this is a kind of a good success story for us. And what it's allowing us to do is really accelerate that app development process. So, going from objectives through to closed loop deployments, accelerating the app development time by 30 to 50%, accelerating the automated testing using network simulations, and trying to speed up the validation with the field teams, because the engineers themselves are the biggest kind of people that gatekeep the automation on the network. And we think as operators truly embrace the autonomous networks, what they're going to need to do is to build these processes in place where they can reliably and repeatably generate new automation quickly and maintain that automation once it's in place. And these are the types of activities we're doing. This was for a North American operator. These are the type of pipelines that we're putting in place. Okay. And like I said, one of the interesting areas is this kind of self-service, bringing in the domain knowledge from the field engineers itself. And the interesting thing is when you speak to engineers, and we have engineers on our staff because we're a managed service provider as well, what you see is a request and a desire to build their own automation. But interestingly, when you go down a layer deeper, there's only 5 or 6 things that they actually want to do on a repeatable basis. They want to audit parameters on the network. They want to check configurations on the network. They want to run one-off activities around special events. And a lot of them just want to export the data to Excel. And so by packaging up these very, very, these key activities they want and building simplified workflows around them, what an operator can do is make it very easy for engineers to kind of build this automation themselves and build up this volume of automation that they're doing. And so I think this is going to be one of the game changers in terms of building kind of extended automation sets. Okay, so that's kind of creating the feedback loops. That's how you go from an open platform to an open platform populated with new automation capabilities, automating hundreds of different use cases. But then how do you expand that platform with new capabilities? And I think the argument we want to make is that there is a headlong rush to agentic and building agentic automation. But I think there's some really nice intermediate steps which bring value to your current engineering teams and ensure that these type of capabilities get adopted before the agent side gets hold of it. So this is an incredibly detailed diagram, but I'll talk you through a little bit. So I've said here, agentic automation is the probable destination. I think there's so much momentum in the industry behind agent technologies, behind this kind of intelligent, kind of robotic approach where using the LLM capabilities, using technologies like MCP, agents themselves can kind of make intelligent decisions on the network. And I think, I don't think it's going to be the autonomous car kind of thing where it's always permanently 5 years away. And I think ultimately this will become reality. But I think one of the interesting things is there's a lot of capabilities that need to be put in place for this. So, at the bottom, you have these open automation platforms that provide the data sets, that provide access to automation engines, AI and ML models, and digital twins. And then on top of that, you have this NCP layer that feeds this information up to agents that can start to make intelligent decisions. But one of the key things in this is that there's this tooling layer in the middle, where for agents to properly work, they need this MCP layer providing the context around activities and data, but they also need these tool capabilities underneath. So they need reliable ways of controlling apps, for accessing digital twins, for looking at the data that's coming from the network. And I think the big industry focus should be around building these type of capabilities first. And the interesting thing is, by building these capabilities now, what you can do is provide useful capabilities for your intelligent agents that you already have, your engineers, but then you're also providing the foundations for this future agentic approach. I think a top-down agentic approach is a very risky one for operators to take, because it kind of puts all your eggs in the pure agentic basket. Whereas being pragmatic and building this tool layer as well will get you to a win, even if the agentic layer takes longer to pull through. So let's talk about an example of what that means. So one of the great kind of recent innovations in the industry is around RAN simulation and digital twins, brought through by companies like NVIDIA. And for the last year, we've been building some very advanced radio digital twins with our customers that do various types of beam level simulation on the network itself. And there's some really cool use cases that come out from it. From very simple things like massive MIMO gain analysis or cell outage compensation using simulations, to really cool things like floor level building simulations. So this is a really, really powerful capability. But the interesting thing about this capability is you need to stop it just being another tool that an engineer switches to. And what you want to do is wrap it up in a way that can be consumed by engineers and can be part of processes that will ultimately become agentic. So I'll show you another screen. I know it's I don't know if it's like the right thing to do to mention one event at another event, but earlier this year we won a FutureNet award with an operator partner that we're working with in Asia around these radio access digital twins. So this is a part of the city of a downtown area in an Asian country. And what you can see that what we're doing is dynamically showing the performance of the coverage and experience at the ground level, but also at individual building floors. So this is a very groundbreaking capability. And because you've got access to NVIDIA and the powerful GPUs, you could run simulations in real time. What if a cell tower goes out? What if population or people move to a certain location? What will happen in terms of special events? So this is a really powerful capability, but then it becomes how you adopt that capability itself. And this is where these agentic-ready workflows come in. So how do you work with an operator customer with their engineering teams to understand the tool progression that they go through? So how do they go, in this case, around optimal site location? How do you go from them understanding which problem areas to focus on, where there is poor coverage? How do you go from deciding which of the best site locations are there and using that RAN simulation to do that? And how do you work with them to understand what steps they go through for validating the outputs and creating a business case for deploying a new site? And this activity of capturing these steps in the workflow has kind of three benefits. The first benefit is you can really quickly create products around these different tools to snap together these workflows in a very simple user interface. Secondly, it allows you to open up the individual components of this step to chat interfaces where the engineers themselves don't have to learn a user interface. They can interact with the steps, one step at a time through a chat interface and get the same results. And then finally, you've now captured an entire workflow that when you plug in the agentic layer that sits over top, you've got a captured end-to-end process that can be used and run automatically. And I don't think there's kind of any shortcuts on this. At some point, there has to be a domain knowledge transfer from the organization, from engineers, into these agentic layers. And we think kind of starting with this kind of step-by-step process, build out the tools, you're building really solid foundations that these agentic workflows can build upon. Okay, so this is my final slide, but hopefully you've kind of got a picture of kind of Amdocs being in this space, working very closely across multiple operators and multiple vendors and having some real kind of insights into what's going on in terms of the autonomous RAN. And I think hopefully I've shown that openness remains kind of critical. So keeping your networks and your automation systems as open as possible ensures the greatest chance of success. And I think hopefully you've seen that from our work with operators, how we're starting to create these kind of positive feedback loops that encourages greater automation to be created. So creating automated ways to getting automation into the platforms themselves. And finally, I hope you've seen that we're starting to adopt these really pragmatic approaches to increasing the capabilities by introducing new tools, but these tools can be used by the engineers themselves as well as the agentic layer that is to come. Okay. Thank you very much for your time today, and we'll look forward to seeing you on the booth. Thank you.
I'd just like to extend a huge thank you to Neil and the Amdocs team for putting on the first presentation on the acceleration stage.
That's okay.
FYUZ 25. As always, they make it amazing, and they really did. So huge thanks. As Neil said, you can find them over here. I think you've got a meeting room upstairs. There's lots of places you can find Amdocs. Do come and find out about the demos that we were talking about. So thank you so much for everything.
No problems. Thank you.
Thank you.